We're now going to talk about one of the most important concepts for the first half of this class, utility. Utility is this idea that when a consumer buys goods or consumes goods, they are made happier. So the consumption of a good provides utility to its customer or its consumer. Eating pizza, wearing clothes, watching movies, attending concerts are all things that benefit the people who consume them. We will use utility functions to quantify the amount of happiness or usefulness that customers will get from consuming these goods. Now, for the purposes of this class, we're going to say that it's possible to have fractional amounts of goods. So even if you might say you can have one beer or two pizzas, we might also say you can have half a beer or 2/3 pizzas or even decimal values of that. We will also say that quantities of goods cannot be negative and they can be zero. So I'll keep those in mind. We're talking about economics here. You really can't have a negative amount of pizza. So fractional values of pizza and even a zero amount of pizza would be a valid value for what we're going to be consuming. Okay, so let's look at some utility functions. Suppose that Andy's utility function for pizza and beer, so pizza is x, beer is y, is given by this utility function here, x squared times y. Which bundle gives Andy the most utility? Well, each of these answer choices is telling me is that you have a certain bundle of goods. It's a basket containing some amount of pizza and some amount of beer, and according to the function, it will bring me some level of happiness. We can figure that out by plugging these numbers into this function. So this says 2 pizzas and 3 beers. That's another way of saying x equals 2, y equals 3. Or so I'm going to go evaluate my utility function at that coordinate, 2, 3. Plugging in 2 here gives me 2 squared is 4. Plugging in 3 here is 3 times the 4 that we got is going to be 12. Let's look at the utility for these next bundles. So this does 3 pizzas and 1 beer. What will my utility for 3, 1 be? Plugging in 3 squared is 9 times 1 is 9. And then we've got one more. We've got x equals 1, y equals 6. When we go to plug this in, 1 squared is 1 times 6 is 6. So the bundle that gives me the most utility, the most happiness, is this bundle here. I get the most enjoyment from this bundle here. Now, what's interesting is that different people have different preferences, right? Apparently, this utility function was such that I picked a bundle that gave me 2 pizzas and 3 beers. But different people, like I said, have different preferences. Let's say this is another version of me, or maybe it's me on a different day. And maybe my utility for pizza and beer is now given by this function. And we're going to recalculate what each of these bundles is going to give me, or for utility-wise, when I plug in those values. So what I'm going to do now, I'm going to do u of 2, 3 again. Plugging in 2, plugging in 3 gives me 2 plus 3 is 5. What about 3 pizzas and 1 beer? So this is going to be u of 3, 1. 3 plus 1 is 4. And then 1 pizza and 6 beers. I get 1 plus 6, which gives me 7. Now notice, this different set of preferences gave me a different bundle that I prefer the most. So it's something to keep in mind, is that different functions will give rise to different preferences. It's not always the case that 2 pizzas and 3 beers is always going to be the winner. It depends on what people prefer. Some people like beer more than pizza. Some people like pizza more than beer. All right, we've got one more. Suppose that Andy's utility function for pizza and beer is given by this wacky looking guy. So first off, I'm not using x and y anymore. I'm using x1 and x2 just to get you guys comfortable with this idea of either using x and y or using x1 and x2. Which bundle gives the most utility? We have this weird function, min of x1, 3x2. Let me show you how this function works. So once again, I'm going to be plugging in 2, 3 into this, which would be min of 2, 3 times 3. The min function, the way it works is it looks at the values that are inside it and takes the smallest one. So in this case, 2 and 9, the smallest of those two values is 2. What if it's the same number? So some people ask me, well, Andy, what if it's min of 7, 7? What's the answer then? Well, of the two numbers, the smallest number is 7. So the min of 7 and 7 is 7. All right, let's keep going. What about 3 pizzas and 1 beer? So utility of 3, 1 equals min. Now if we're plugging in 3 for x1, we're plugging in 1 for x2, but then we're multiplying it by 3, so it's going to be 3, 3. And the min of 3 and 3 is 3. Lastly, utility of 1, 6 equals min of 1, remember the second argument is 3 times whatever x2 was. This is x2 is 6. 3 times x2 3 times 6 would be 18, but the smallest of the numbers here between 1 and 18 is 1. So here, my preferred bundle is answer choice B. And all of this was to show you that, one, there are different types of preferences. There's these preferences that apparently this bundle was the winner. There are these preferences where it seems as though this bundle is the winner. And there are these preferences where it seems as though this middle bundle B is the winner. Great. Okay, we're going to move on into indifference curves. If two bundles provide the same level of utility, we say the consumer is indifferent between the two bundles. For example, consider the utility function below. The bundle consisting of 3 units of good X and 4 units of good Y provide the same amount of utility as the bundle consisting of 2 units of good X and 6 units of good Y. Let's see that in action. What is U of 3, 4? Well, when I plug in 3 here for X and 4 here for Y, I get 3 times 4, which is 12. On the other hand, I could be looking at the utility for the bundle 2, 6, where I plug in 2 for X and 2 for X and 6 for Y, and that again gives me 2 times 6, which is 12. So I get the same result. This would suggest that the consumer is equally happy choosing 3 units of X and 4 units of Y as they are between choosing 2 units of X and 6 units of Y. Okay, and by the way, there's many more points than just these two, right? I probably could have done something with some weird fractional values, right? In fact, with fractional values allowed, there are an infinite number of different bundles that I could have picked using these values. Like I could have chosen, let's grab a calculator here. Let's suppose I chose X to be, let's say, I'm choosing X to be 6.667, okay? So 6.6667 is my value of X, and let's say I choose 1.8 for my value of X, or for my value for Y, I should say. Sure enough, when I multiply them, I get pretty darn close to 12. So I just want to show you that there are many different points, in fact, an infinite number of different points that will produce the same utility for this curve. All bundles that produce a given level of utility can be drawn graphically in the following way. This is an indifference curve. I guess I should put that in the blank down below. This is an indifference curve. Indifference curve. And we could even like plot some of these points. Remember we said 2, 6 was this point, and it brought us some level of happiness. Remember our utility here was 12. But also the coordinate 3, 4 is also a bundle on this curve. So there's 3, 4. Here's 2, 6. Since both of these points are on this curve, it shows that they are the consumer is equally happy between these 2 points on the curve. Let's do an example. Complete the table below. I'm going to move my big dumb head a little bit, make myself transparent. Ooh. Complete the table below with bundles that satisfy the utility function x1 times x2 plus 1 equals 12. Or I'll put it over here. x1 times x2 plus 1 equals 12. What you're going to do is plug in each value of x1 into this utility function, then find the corresponding value of x2. So let's get started. If I plug in 2 for x1 here, I'm going to do this in green. I get 2 times x2 plus 1 equals 12. And if I go solving for x2 from here, I'm going to divide both sides by 2 and subtract 1. Gives me x2 equals 5. Okay, let's do it again. I'm now going to plug in 3 for x1. Solving for x2, I'm going to divide both sides by 3. This gives me 12 divided by 3 is 4. Subtract the 1, I get x2 is equal to 3. Let's do this over here. I'm going to plug in 4 now. 4 times x2 plus 1. Again, we're still setting it equal to 12. And solving for x2. Dividing both sides by 4 gives me x2 plus 1 equals 3. Which then tells me that x2 is equal to 2. We've got this bundle. And lastly, when x1 is equal to 6, I end up with x2 equaling 1. So we've got these bundles. Let's plot them on the same indifference curve. Okay, again, why are these all, by the way, just to remind us, why are these all going to be on the same indifference curves? Because these points, when plugged into this utility function, always give us a utility of 12. So 2, 5, 3, 3, 4, 2, and 6, 1. So here we have that indifference curve here. Every point on this curve indicates a utility of 12. I want you to, before we wrap up this video, I want you to notice the shape of these indifference curves. It's this this kind of concave shape that we expect to see, or so we call this concave up. At least in calculus, we call this concave up, but some professors call it convex. So just bear in mind what kind of terminology is being thrown around. But typically, what we want to see is indifference curves that have this concave up shape, and that's kind of a property of something we'll talk later about, the marginal rate of substitution. We'll see that though in some later video. Thanks for watching. My name is Andy, and if you found that video useful, we've got plenty more videos just like it. We're giving away a free month of membership, our essential membership to GPA Factory, a free month of it. If you want to get it, just go to this URL and use code YouTube100 to start learning from one of the best to ever teach it. That's me. See you guys soon.